Hello, I am Dargis, engineer from Construction, Dargis. Today I want to talk to you about the following topic: detection, prevention, and alarm of snow and ice overload on the roof. Each winter, when there are large accumulation of snow and ice, roofs, large or small, are at risk of collapsing if there is no constant roof monitoring and maintenance program in place. A constant roof snow and ice cleaning control program can be very expensive. It is therefore useful to know when a snow removal intervention is required to limit the expenses, especially in the case of large roof. I am often called upon as an engineer to verify if the load of snow and ice on the roof is not excessive and does not represent a danger, and to make recommendations consequently. Fortunately, today there is an electronic wireless monitoring surveillance real-time detection system of the load on the roof structure. This is what I want to talk to you about today. But first, I want to put you in the right context with different roofing situations to watch out for. As a first case, it is necessary to monitor the flat roofs of old buildings whose roofs have recently been insulated but which do not meet the current structural standards of National Building Code. Why should these roofs be monitored? Because before being insulated, these roofs cause snow and ice to melt through their heat loss. However, once insulated, these roofs now often accumulate heavy loads of snow and ice, which cause a danger if there is no constant maintenance or reinforcements of the roof structure. It is for this reason that serious roofing companies, when they receive a mandate to redo the roof and better insulate it, recommend the intervention of a structural engineer to check whether the structure of the roof must be corrected in order to prevent collapses and ensure the protection of the public. Another case are commercial or industrial buildings with different roof levels, causing gusty corners, snow buildup, or drains that get clogged and cause ice accumulation. So let's go and see together what these large commercial buildings roofs look like. Here you can see the differences in levels where snow can accumulate, and the drains that can clog and allow for ice accumulation. These are just a few cases among many others that require monitoring and maintenance. So here is how the roof overload monitoring system works. It is an electronic system like this one that is installed at strategic location on the roof structure and that accurately measure in real time the forces and load applied to the structure. Here is a small setup to better understand how it works. It is a resistive foil strain gauge that is been glued to a metal bar, actually representing a steel beam on the roof. The sensor is connected to a transmitter with an antenna to send the signal to a local server with a range of about 1 kilometer. The local server receives all the signal from all the sensors like this one and is equipped with a SIM card to transmit the signal to the cloud. The metal bar represents, as I mentioned, in reality, a beam which can flex under the weight of the load of snow or ice. On the other side, I have my computer with a USB receiver and software to monitor all the signal coming from the cloud. So I'm going to simulate a snow load on the roof by applying a weight with this block of masonry to the steel plate. Now you can see the information that is received on the software of my computer. I can add another weight and see the variation in loads applied to the structural element immediately in real time. Likewise, I can remove the charges and see the return of the structure to the normal point again. All this without wires and in real time. Moreover, all this information is recorded over a long period of time, days, weeks, and months. I can get a picture of how the building reacts precisely and in real time. By first analyzing the roof structure of the building, it is therefore possible to determine where to install the sensor and when to issue a snow or ice alert. Of course, there is a whole procedure to follow in order to properly install the sensor and calibrate them correctly. By the way, the wireless transmitter of each sensor are equipped with a battery with an average life expectancy of 5 to 10 years. There are several other types of sensor for doing all kinds of structural monitoring, whether it is to monitor the forces and load on the structure, vibration on a building or products produced by equipment, movement of concrete cracks, tilt change and other sign of instability, surveillance camera, water level, and others, with multiple applications. Everything to monitor the structural health of buildings and equipment. These systems are relatively expensive and are used more for commercial buildings, public buildings, industrial equipment, faraway reservoir and tanks, bridges, and more. Do not hesitate to contact me to install a structural monitoring system and to provide services of structural surveillance. As in the present case, the prevention of snow and ice overload on the roof. Thank you, and see you next time.